Alright, welcome. This is chapter 5-1. This is called Rate of Change and Slope. Now, if you were watching the chapter 4 videos, you should know that I mentioned slope a couple of times, and now I get to explain what slope is. Okay, so slope is a rate of change. A rate of change is basically how fast something is going. So slope is how fast something is going, basically. Okay. Rate of change is also modeled in a rate of change is modeled with this equation, I would say. So rate of change equals change in what I'm going to say is y over x, because that's all you need to know. Okay? Change is y over x. It's also known as slope, like I said, and slope is also known as rise over run. I learned this in about, third grade, I think. My teacher's name was Miss Jane Hotchkiss, I believe. I think that's what her name was. Anyways, so she taught me rise over run, over and up. Yes, okay. So, rise over run is slope, okay? So, let's do an example. This is actually kind of fun. Fun for me. I don't know if you like it. We'll find out. Another way to, there's lots of ways to model slope, apparently. So, one of them is y2. If you're given, in this scenario in which you would use this method to find the slope, you want to use 2 points where you're given x comma y and x2, so y2, okay? All right, and since these are 2's, I'm gonna call this 1 and 1, okay? So this is the formula you will use every time. It is called the formula for slope, I guess you can call it. So you take this one and subtract this one, and then you take this one and subtract this one, but the x's are in the denominator, okay? So you take y2 minus, let me do it in a color, y2 minus y1. Put your fraction line, x2 minus x1. Now, these aren't exponents, these are just to model that the number in the second coordinate relation is subtracted from the first. Now, it'll typically work out whichever way you do it, as long as you correctly notice that the y's are subtracting from the y's and the x's are subtracting from the x's. That being said, my point I'm trying to make is, using this formula here, if I have 3, 8 and 4, 2, but we don't know which order it came in, whether we subtract 2 from 8 or 8 from 2 or 3 from 4 or 4 from 3, it doesn't really matter, because either way you will get the same answer, surprisingly, because let's say we do it one way. Let's say we do 2 minus 8 and 4 minus 3. 2 minus 8 gives us negative 6, and 4 minus 3 gives us 1. Let's do it the other way. 8 minus 2, I drew out that 8 correct. 8 minus 2 over 3 minus 4. 8 minus 2 is 6, divided by 3 minus 4 gives us a negative 1. Guess what? This and this both equal negative, negative 6, there we go. Therefore, our slope would be negative 6 in this point right here, okay? So, whichever order they came in, we know that the slope is going to be negative 6, because either way, you will get a slope of negative 6. As long as you plug in the y's to the y, which are the numerator, and the x's to the denominator, you will get the correct answer, okay? Alrighty, so let's see. Let's do another example. That formula, you should memorize. That's a good one to memorize. I would suggest just write it over and 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 over again. This is a formula you need to know forever, okay? So let's say you have, let's see, -2, 1, and 6, 7, okay? So we're going to use this formula right here. y2 minus y1. Either way, you'll get the same answer like I said, so let's just do it the way we normally know how we do it. 7 minus 1 and 6 minus -2. This is a minus sign. 7 minus 1 gives us 6, and 6 minus -2. Remember, when we subtract negatives, we add the opposite. Therefore, 6 plus 2 just gives us 8. And let's see. So now we have 6 over 8. We can even simplify it if we want to, because 6 over 8 is the exact same thing as if we divide by 2 on the top and the bottom. 6 divided by 2 is 3, and 8 divided by 2 is 4. Final answer is 3 over 4 or 6 over 8, whichever way, doesn't matter because it's the exact same answer. But if your teacher wants you to simplify, I suggest you go with this answer. Cool? One more thing I want to teach you before in this section, that is what a zero slope is and an undefined slope. These are two different things, okay? Zero slope and an undefined slope. A zero slope looks like this. And you have zero slope looks like a straight line going from left to right, okay? A undefined slope looks like this. Looks like a line going up and down, okay? Now, there are two more things you need to know, which is a positive and a negative slope. What's a positive slope? A positive slope is this. It's going up, okay? It starts down here, and it starts down here, and it makes its way up here. It goes from left to right, going up, okay? Let's see. A negative slope looks like this. I don't use white, I use blue. Looks like this. It's going down. From left to right, it goes down. You always look at the graph from left to right. That's how you tell where it came from and where it is going. Okay? Alright. Okay, so now we're in chapter 5-2. This is what's called slope-intercept form. Slope-intercept form. Slope-intercept form. Slope-intercept form looks like this. There we go. That's what slope-intercept form looks like, okay? Now, that looks like a foreign language to you, probably. So let me break it down. You're familiar with our y, and you're familiar with our x, and you're familiar with our plus sign. What you aren't familiar with is, what the heck is this? What the heck is this, all right? So, I will tell you, students, this M represents slope, okay? We covered that in the last chapter. Slope can be positive, negative, 0, or undefined. Remember that. Alrighty. Positive slopes go up, negative slopes go down, 0 slopes are horizontal, and undefined slopes are vertical, go up and down. And B, over here, stands for y-intercept. This is how you graph. This is how you graph. Okay. Anyways, so y-intercept is modeled by B. I don't know why they chose B to model something that has y-intercept in it. Why would you use a letter that has nothing to do with the spelling of y-intercept? But hey, I didn't make it. So this is slope-intercept form, okay? So So for example, let's say I have y equals 1 over 2x plus 2, okay? 1 over 2x plus 2. So what this is going to look like is this. Okay, so it looks like this. Y equals 1/2 x plus 2. Now let's zoom in for a closer look. You obviously see right here is our graph, right? Or what our equation looks like. Now, there is a point, let's see. There's a point here, there's a point here, there's a point here, okay? So, notice that the dot right here is at -2, 1, and this one is at 0, 2, okay? So, I like this because I can give you a perfect visual representation of what this looks like now. So, I'm going to use black, okay? So, what the graph looks like is, obviously it's a positive slope. Because it's going up, right? And we also know that to get from point to point to point, it goes up 1 over 2, up 1 over 2, and if it wasn't cut off, we know it would be going up 1 over 2, and it'd be at this point right here, right? Okay, blue. So, this here, come on now. This here, this increase, 1, 2, 3, is consistent throughout this entire line. It'll keep going all the way up here and all the way down there in a constant consistent pattern just like that, okay? Now, the pattern represents the slope, okay? So we have y equals 1/2 x plus 2. So we know that the graph is right here, right? This is the graph. 1/2 represents the going upness at a positive. It's a positive slope because there's an imaginary plus sign here. We know it's positive because there's no negative sign. That's basically it, okay? We also know that the fraction tells us the rise over run. We learned this in the last chapter, okay? Slope is also modeled with m, okay? So I'm gonna stop writing out slope. I'm just gonna write m now, so now you know what slope is, okay? If you don't, pause this video and write it in your notes. M equals rise over run, okay? So with this formula right here, or the formula right there, we know that the rise here is 1 and the run is 2. What did we do in the graph? We rose once and we ran twice. We rose once, we ran twice. It happened over and over again. Therefore, this gave us our graph. Now, that's all fine and dandy. Let me do it again. Bam, okay? So let's zoom in again. We know that this is 2 and this is -4. We don't care about the -4 as of right now. What we do care about is how do we graph this? How do we know where it exactly is, right? So we know that right here is 2. That is our y-intercept, remember? Now, I'm not going to write y-intercept anymore. I'm going to write b, okay? So remember this, put it in your notes, okay? So b is 2. And we know this because what we do is when we're graphing something, we start at 0, 0, and then we go to where the y-intercept tells us to. The y-intercept is, think of it this way. We know that this line right here, the up and line is the y-axis, yes? Now, with that logic, if we have something that's called an intercept, for those of my students that watch football, we know if you take an interception or you catch an interception, we know that somebody on the opposite team caught the football, right? On defense, caught the ball from the quarterback, right? Now, what that's basically saying is this line, which has nothing to do with our original line, which was right, I don't have it, right here. Our second line crosses it at exactly 1 point, and that 1 point is right here at what? 2. Okay, so it crosses at 2. That is our B. Okay, so B equals 2. That is the y-intercept. Okay, cool. So in order to graph something, if we have a blank graph, bang, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, and we have y equals a half. Remember what our graph is? Y equals a half x plus 2. What you do is you start at the origin, 1 2, put a point. We know that the slope goes rise over run, rise 1 over 2. Another point, rise 1 over 2. Another point. And then you do the exact same thing in the opposite direction. So now we're going to rise 1 over 2, but now we're going down 1 over to the left 2. So down 1 over to the left 2. Down 1 over to the left 2. And then I can model this with a straight line in my toolbox thingy, whatever this is. Come on. Here we go. And it is just about accurate. Okay? This is the exact same thing as this, which is the exact same thing as this. Bam. Blowing your mind right now. Okay, chapter 5-3 is what's called standard form. And standard form is another type of equation in which we have to rewrite it so we can get slope-intercept form, which we covered in 5-2. Okay? So, standard form looks like this. If I have, what's the example? Here we go. 5x plus 2y equals -10. This is standard form. They also write it in the letter format as ax plus bx equals c. Okay? Where, did I say ax plus bx? No. Ax plus by equals c. Okay? In which a is a coefficient of x, b is a coefficient of y, and c is a constant. Okay? So, back to the one with numbers in it. So, we have 5x plus 2y equals -10. So, what we need to do is get this to slope-intercept form. And the way we do that is we have to what's called isolate y. Okay? The way we isolate y is we have to get rid of this over here and put it over here. We know how to do that, obviously. Adding and subtracting. So now we bring down everything else. We have 2y equals -5x minus 10. Now we can divide this 2 onto both sides. And if you remember earlier from chapter 4, I believe, I just have y equaling -5x minus 10 over 2. And we know from chapter 4, like I said, that we can break this up. So now we have y equals -5 over 2, x minus 10 over 2. We can simplify this once more. And getting y equals -5 over 2, or equal 5x over 2, either way. 5x over 2, either way the x is multiplied by the 5 or the 5 half together. Either way, it doesn't matter. And then the 10, we bring down the minus sign, and 10 divided by 2 gives us 5. This is slope-intercept form. This is standard form. And this is how you convert this to this. Write this down in your notes. Alrighty? Let's do another one. If I have... Oh yes, I wanted to show you something else about that last problem. Remember how we got from here to here? Went from here all the way down to here? Well, what I want you to do is notice that we have a coefficient of -5 half right here. Okay? I prefer, even though I wrote it this way this time, I'm going to start changing that so that it is now going to be y equals negative 5 over 2x, the x is separate, minus 5, okay? Because what I want you to do is I want you to notice that this is m, this is the slope, and this right here is our b, which is the y-intercept. Remember that. The y-intercept, and I'll write it separately, the m equals negative 5 over 2, which is negative 5/2. This is a negative slope, and b equals negative 5. That being said, we know that this is a negative y-intercept and a negative slope. Just wanted to put that in there. Alright, one more. Let me go from the check yourself. Alright. Here we go. If I have 6x equals y, already it is in it's in standard form as of now, and actually it's in slope-intercept form already, okay? And I'll show you how. Because we can just flip this over here and flip this over here. Either way, doesn't matter. You'll get the same thing. Y equals 6x, 6x equals y, same thing. Now, tell me if this looks familiar. If we have y equals mx plus b, isn't the m right there? Isn't the y right there and the x right there? Now, where's the b, right? So, what I want you to do, just to make me feel better, is put a plus 0, an imaginary plus 0, okay? Now, we have a b. Because y equals 6x is the exact same thing as y equals 6x plus 0. Because you're not doing anything to it. All you're doing is adding 0, which is adding nothing. If you have $5 and I don't take away anything, you still have $5. If you have $5 and I don't give you any money, you still have $5, right? Yes. So, and the way to graph this is you start at your graph, you start at 0, because that is our y-intercept, remember? And let's put our hash mark dashes, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Alright, so we know it's rise over run. When we have a regular number as our slope, we know that every number, if I have like 6 here, we know that every number has a denominator of 1, okay? So if I have, I'll just teach you a side lesson real quick. If I have 13, if I have 18, if I have negative 12, if I have negative 100, we know that all these are the exact same thing as 13 over 1, 18 over 1, negative 12 over 1, negative 100 over 1. You can put anything over 1 and it be itself. Let's see. These are equal, these are equal, these are equal to each other, these are equal to each other, all those equal each other, okay? Back to our problem. So we know that our slope is 6 over 1, so we're going to rise 6 and run 1. Once, twice, 3, 4, 5, 6. We're here, and then go over 1. We have our another dot right here. Go in the opposite direction, the same thing. 1, 2, 3, 4, 5, 6. We're here, and go over 1. Put our dot, and bam, there we go. Oh, let me draw a straight line to show you what it looks like. Sorry. Let's see if I can do that again. There we go. That is our straight line. And one more thing. Don't forget to add arrows on your graphs, okay? I've been noticing that. Add arrows to your graphs, okay? Because that is a line, because it goes on and on and on forever. If you don't add arrows, you're saying that it stops at that certain point. We want arrows on our graphs, okay? This is a positive slope, by the way. Positive slope. Cool.
Alright, this is chapter 5-4, point slope form and writing linear equations. Okay, so point slope form is another one of the forms you need to know. Let's go over the ones you already know, which would be y equals mx plus b. We know this is slope intercept form. We know the other one, which is ax plus by equals c. This is standard form. And the last one, or I believe it's the last one, or the next one you need to know, which is this one right here, which is point slope form, which is modeled by, let's use red, or whatever color this is, I think it's red. y minus y1 equals mx minus x1. This, my friends, is called point slope form. Okay? So, we have, so far in our artillery of formulas, we have slope-intercept form, standard form, point slope form, okay? All of these are quite simple, I think. And, let's see, so basically, standard form, you typically, when you want to graph it, you want to convert it into slope-intercept form. Standard form you want to convert into slope-intercept form in order for you to graph it. You want to convert point-slope form into slope-intercept form so you can graph it. The main important one is slope-intercept form, which is the reason why we learned it first. Okay, so moving on to what point-slope form entails. Okay, so if I have, oh yes, and then there's this formula which helps come in handy when trying to find m. M is here, and m is right here, okay? It comes in handy, which is y2 minus y1 divided by x2 minus x1. That is the formula when trying to solve for m, okay? Now, if I give you the points, so this is what they'll do when they check yourself, okay? They'll give us a point like, here we go. Example 1 will be, here's 6, comma, negative 4, negative 3, comma, 5, okay? And they're going to say, graph that. And, let's see, what does it say? Write an equation for the line in point slope form, then rewrite it in slope intercept form. What did I just say? Write it in point slope form, then rewrite it in slope intercept form, which is this top one right here. Okay. So the way we use this is, remember that this is an x, this is an y, this is an x, this is a y. Okay. Now this right here is our first set of coordinate points, and this is our second set. So what I want you to do is write this, of course, in your notes. The 1 goes next to the x right here. The y goes to the 1. The 1 goes next to the y right here. 2 goes to the x, next to the x right here. The y goes next to the 2 goes next to the y right there. Okay. Now we can now find the slope, or m. Let's do that. 5 minus negative 4 divided by negative 3 minus 6. So we're subtracting negatives, so we're going to add the opposite. Therefore, we get on the numerator 9 divided by negative 3 minus a positive, so we're going to add the opposite. Now we have negative 9. Okay, so now what we can do, is divide. We get 9 divided by negative 9 gives us negative 1. And boom, there we go. Now, that is our slope. That is our m, okay? So now we have that. Boom. So let me write it out now. We have, hopefully you're copying all this down, y minus y1 equals m parenthesis x minus x1, okay? Scrolling down. Now we have y minus y1 equals negative 1, because that's what we got, x minus x1. Now, where do we get the y1 and the x1? Right here, okay? y1 and x1 come from right here. Bam. So now we take this and put it with this. So our y1 is negative 4, so we have y minus parenthesis negative 4 close parenthesis equaling negative 1 x minus, what is it, the 6 I think? Yes, 6. Minus parenthesis 6 close parenthesis. Now, this is the part where we simplify this. So now we have a minus and a minus, so we could just make this a plus. Y plus 4 equals, and then we have, leave the negative 1 there, and we have x minus 6. Bam. Now, we have achieved the goal of putting it into, what is it called? Point slope form? Yes, we have achieved the goal of putting it in point slope form. Now, I want it in slope intercept form, just like the directions say. So what we're going to do is distribute this negative 1 to the inside of these two terms, bring everything else down. Y plus 4 equals negative 1x. Negative times a negative gives you a positive. 1 times 6 gives us a 6. Now, we know how to do this. Subtract 4 on both sides. We get y equals negative 1x. We don't need the negative 1x because we already know there's an imaginary 1 there. So now it's just going to be negative x. And we know that 6 minus 4 bears 2. A positive 2 specifically. And now, I'm going to make it prettier. Y equals negative x plus 2. This is the exact same equation as this here. We only put it in point slope form. Slope intercept form, excuse me. It's the exact same thing. Cool? Cool. All this gave us this. Alright, welcome to the last section of chapter 5, parallel lines and perpendicular lines. Now, parallel lines and perpendicular lines are very easy. Now, parallel lines look like this. Parallel lines, alright, see how I did that? It was already ready to go. See what I did there? Yeah. Parallel lines have the same slope. Alright. They have the exact same slope. Look here. We know that the slope intercept form is y equals mx plus b. And if you don't know that, you need to rewind this video and watch it again, okay? So we know that slope is m. So m, 1/3 is the exact same thing as 1/3. Therefore, these are the exact same slope, okay? Parallel lines are two lines that will never cross. Never cross. You can go this way forever and ever and ever and ever, or you can go this way forever and ever and ever. Either way, if you go this way or this way, they will never cross each other. Never, ever, in a million years, a billion, trillion years, they will never cross, ever. Okay? Those are parallel lines. Okay? Same slope. Remember that. What do parallel lines have? Same slope. Good answer. Good. Now, two perpendicular lines. See how I already had that ready? See what I did there? Yeah. See what I did there? Yeah. Okay. Anyways, perpendicular lines cross at what is called a 90-degree angle. Or, in other terms, a right angle. I put angle. Forgive me. My major was math, not English. Right angle. Okay. A
right angle is what we have right here. This crosses at exactly 90 degrees. Therefore, giving it a little pretty box in the corner, like a square or a rectangle, that is a right angle. I'll make it bigger. Bam. That is a right angle. These are perpendicular lines because they cross at 90-degree angles. Now, what is the relationship between perpendicular lines? Slopes. They have what are called, make the line thin again, opposite reciprocal slopes. Now, what are opposite reciprocal slopes, Jamari? I will tell you, student. Opposite reciprocal slopes. Think of it this way. Okay? We have 1/3 and -3, okay? 1/3, -3. This is an example of an opposite reciprocal. Let me do another one. If I have 1/5, it will become 5/1. If I have 2/3, it'll become 3/2. If I have 8/9, it will become 9/8. Are you seeing the pattern here? This, my friends, is what's called reciprocal. It's basically you taking something like this. Let's see. I take something like this and flip it. You take this reciprocal, flip it. Take the reciprocal, flip it. Take the reciprocal, flip it. Take the reciprocal, flip it. I'm sorry, I'm just having fun. So, you take the reciprocal and flip it. Okay? That's what you do to numbers that are reciprocated. Okay? Now, what are opposite numbers? Quite simple. If you have 8, if you have -4, if you have 5, the opposite is -8. The opposite is +4. The opposite is -5. If you have -12,000, the opposite is +12,000. All right? That's what that is. Cool beans? This is opposite. So, back to our graph. Perpendicular lines have opposite reciprocal slopes. That means that M, this thing here, when there's a relationship between them, it'll be the opposite of each other, and meaning it'll be one will be positive, one will be negative, and one will be reciprocated. That means one's going to be that means one's going to be flipped like this, and the other one's going to be flipped like that. One's going to be flipped like this, one's going to be flipped like that. I'm sorry, I'm having a lot of fun with just spinning this arrow. Okay, anyways. Cool. So, I believe that's it. Let's do an example from the book. Basically what it'll do is it'll ask, are these lines parallel, are they perpendicular, and such and such. And what you'll have to do is manipulate different equations from point slope form and standard form. This is what we learned, by the way, in this entire chapter. Point slope form, standard form, slope. Let me do this different color. Slope intercept form, I abbreviated. We also learned y2 minus y1 over x2 minus x1 equals m. We learned, let me write these out, by the way, next to it. Point slope form is this one, y minus y1 equals mx minus x1. We learned standard form, which is this one,
ax plus by equals a constant. We know the slope-intercept form is this one. Y equals mx plus b. We know that y2 minus y1 equals divided by x2 over x1 equals m. We know that m equals slope, which is equal to rise over run. What else do we learn? Oh, we know what that parallel lines, we know that they never cross, and they have the exact same slope. We know that perpendicular lines cross at right angles, which is 90 degrees, and we know they have opposite reciprocal slopes. Okay. Let's see what else. We know that opposite reciprocal, opposite is if you have -5, it becomes +5. We know that -3 becomes 3, 8 becomes -8. That's what opposite means. We know that reciprocal means the arrow, remember? So if I have 4 over 5, it's going to, where's my arrow? There's my arrow. It's going to flip like that. So it's going to be 5 over 4. We know that if it's 8 over 9, it's going to be 9 over 8. Because it went from here to flip. And hopefully I'm hopefully I'm beating a dead horse. You know what all these are. Yeah. So, review, point slope form is that one. Standard form is ax plus by equals constant. Slope intercept form is y equals mx plus b, where m is slope and b is the y-intercept. I'm gonna write that. Y-intercept. We know how to find m in given circumstance. y2 minus y1 divided by x2 minus x1 equals m equals slope equals rise over run. Parallel lines never cross. They have the exact same slope. Perpendicular lines cross at right angles, 90 degrees, and have opposite reciprocal slopes. Opposite slopes. Opposite means -5 goes to 5, -3 goes to 3, 8 goes to -8. Reciprocal slopes mean we have 4 over 5, 5 over 4, 8 over 9 goes to 9 over 8 because it flips. Alrighty. Anyways, hope you learned a lot in chapter 5.